Hi, chemistry. Today I'm going to talk about acid strength. A lot of this we've kind of already seen, but now we can talk about it in terms of Bronsted-Lowry ideas and conjugate acids and bases. So today's kind of more like a cleanup, potpourri day, cross some T's, dot some lowercase j's, so we can move on. Alright, so I want you to consider the ionization of acetic acid. Uh, Under standard conditions at this concentration, it only ionizes, excuse me, 1.3% the water comes in contact with, which isn't that much. Now, there's a couple ways we can interpret that. We can say that the water does not strongly attract a proton from CH3COOH, the acetic acid, and it would be this proton. That's why they write it like this. Okay. But another way of looking at it is that this part of the acetic acid molecule really strongly holds on to its proton, more strongly than H2O attracts it. So you can think of that as the acetate, like this part, is a stronger base than the acid. So that this weak acid has a fairly strong conjugate base. That's what I want you to think of. So again, this is the conjugate pair. If the acid doesn't ionize very much, it means that its conjugate base holds onto the proton strongly. Okay. The extent of the ionization, we've seen this, determines its relative strength. This is the big idea though. The weaker the acid, the stronger its conjugate base. Okay, so I want to talk about that again. I'll repeat myself. So if an acid does not ionize much, like this one here, it's because that the conjugate base, this part of the acid, really strongly holds on to that proton. So water can't grab it. Okay, so a weak acid has a strong conjugate base. Converse is true, a strong acid has a weak conjugate base. Talk about that over here. One thing I don't want you to forget is that strong acids ionize quantitatively. That's why it's a single arrow, so that's 100% yield. Okay, so hydrochloric acid's a strong acid. All of it will ionize with water, and you'll be left with chloride and hydronium. Now check this out. The conjugate base of a strong acid can't even attract a proton from hydronium, the strong acid, okay, because the reverse reaction doesn't occur. This means that if you put chloride in water, it doesn't affect the ionization of water because it contributes nothing to it. It will not affect the pH of water. Okay, so again, this might look silly, but this is kind of the ionization of water would look like this. Oops, already messed it up. Okay, and it does occur. Okay, but if you throw chloride in there, it doesn't affect anything. It can't even. It won't interact with any of the hydronium in pure water. This doesn't occur. Okay, so if you have chloride floating around, it'll just float around. It's not going to affect the pH. It won't affect this equilibrium. Okay. So any strong acid, its conjugate base isn't even a base. Okay, because it doesn't affect the pH of water.